And to this, I can connect this here, for example. And I connect this one here. And I connect the third one to this point. So I have two options. Either, now let's say this is A prime, B, P prime, C prime. So I either connect A prime to B prime, then I have to connect B prime to C prime. So it's the same. What you do to the phase A, you have to do it to the phase B. Or you can connect A prime, that's the other option, to B, not to B prime. That means B prime, you have to connect it to C. And C prime, you have to connect it to A. Those are the two options you can do. You cannot think of any other option. A here, either connect it to B prime or B. Someone would say maybe I can connect it to C prime or C, but that is exactly the same thing you're doing with the B. It's just you're changing the order. Instead of going to A, B, and C, you go to A, C, then C, B, then B, A. So those are the two connections we can have. There's no other options we can do. Two type of connections to connect the three phase sources together to make one single three-phase source. Is this okay so far? Like, we have to connect one side to the load and the other side we have to do something with it, the other terminal. Now this connection here, this one here, when we connect the terminals all together, is called Y connection. And we will see why. And this is called delta connection. Okay. So one more time. This is called Y connection when we take the terminals A prime to P prime to C prime all connected together. If we do A to B, B to C, C to A, that is called delta connection. So this is the Y connection. This is delta connection. Now we will see why this is called Y and why this is called delta. We're gonna take Y first. Okay, so I'm gonna delete all. I'm gonna do Y connection. This is why called Y. Remember, it's an AC source. Those are the terminals here. That's going to the load. Now this connection, I can draw it in a different way. This is A, this is B, this is C, and this point, the common point, I call it a neutral. It's a common point. This, I can draw it like this. This is the point A. This is the point B. This is the point C. This is the neutral. So this is the first source. The positive here, the negative here. This is the second source. And this is the third source. So I just redraw this one. To be like that. It's exactly the same. You see the terminals A, B, C. From A, they have a voltage source to the neutral. From B, I have another source to the neutral. From C, I have another source to the neutral, which is this common point here, called the neutral. Now, if you look at this shape, it looks like Y. So this is why this connection is called Y connection, because it can be redrawn as a Y here. So this is Y connection because it looks like Y, even if when I connect it this way, it can be drawn like this, so it looks like Y connection. Sometimes people do it like this and it's still like Y connection. Sometimes you do it like this and it's still Y connection, because that is one, this is another terminal, this is a third terminal, those are the three terminals. Is this okay so far? So one way to connect the source or to connect the load of three-phase source or three-phase load is to connect it Y. How to connect Y? You take the negative terminals all together and you leave the other ones to be connected to this load. Any questions so far? Now we will look what happens when we have Y connection. Okay, so I usually draw Y like this. I find it kind of easier, but this is still Y connection. So this is A, this is B, this is C. I'm gonna put numbers here. AC voltage, AC voltage. Look at the negatives are connected together, okay, to the neutral. And this is called the neutral point. Okay. So the voltage between A and the neutral, let me just give it a number. Let's say 120 angle 0. Now, if it's ABC sequence, this will be 120 minus 120. Maybe I should have changed the numbers, not 120. Let's make it like 240, just to differentiate, because I don't want you to be confused between the angle and the, so 240, let's say. And 240. The third one will be 240, and the angle will be minus 240 or plus 120. Those are the three voltages generated. Phase shift between them 120 degree. Okay, A, B, C sequence. This is A, B, C sequence, the more common. Okay. Now, if we look, what is the voltage between A and N? It means between the point A and the point N here. This voltage, it's 240 angle 0. Then if I go between B, which is this point, and the neutral, I'm going to find this source. So VBN is 240 and angle volt minus 120. Then VCN is 240 and angle 120. Okay, so those are three voltages here. Between neutral and the point A, between neutral and the point P, between neutral and the point C. The voltage here, between here and here, is called phase voltage. So those three voltages are called phase voltages. Why? Because they are cross the phase. What is the phase? Is the single phase source here. So it's the voltage cross this and the voltage cross this. So these are phase voltages. Okay. Now there are other voltages like between here and here, between this point and this point. between A and B. There is a voltage VAB. Then there is a voltage VBC between here and here. Then we keep the same order. There is a voltage between C and A. B, C, and A. So this is phase. Those voltages we call line voltages. Why we call them line voltages or line to line voltages? The reason, because between line and line. This is between point to the neutral, cross the phase. So call it phase. This is between line to line from this is the source. And this is the lines going to the load. So between the lines, we call them line voltage or line to line voltage. So a concept, if the voltage between line and another line, we call it line to line voltage. Now we're going to try to find what is this voltage. Now, if someone say find the voltage Vxy, how do we find the voltage between the points X and the point Y? Any answers? It's Vx minus Vy. So what is the voltage VAB?
VA minus VB.
VA minus VB. So it's the voltage at the point A minus the voltage at the point B. What is the voltage at A? In this example, it's 240 angle 0 minus 240, the voltage at B, minus 120. What is the answer here? Can anyone put it in the calculator and find the answer?
$415, sir.
415, and the angle?
30.
30. Okay, now the good thing about three-phase system, when it's balanced, if you want to find VBC, you know it's the same value. 415. 415. And the angle, you're going to take the 30 minus 120, so minus 90. And 30 plus 120 is 150. You can do the same thing. You can do VB minus, I will write that just so you know what, and how can we get this if we're not. So it's VB minus VC. So the voltage 240 minus 120 minus 240 plus 120. It will give me 415 and angle minus 90. Here VC, which is 240 angle 120 is VC minus VA, and VA is 240 angle 0. This is gonna give you 415 angle 150. So I have 3 phase voltages and 3 line voltages. Look what is the relationship between them. See what happens here. The angle here is, for the first one, 0. The angle here is 30. The angle here is minus 120. The angle here is minus 90. The angle here is 120. The angle here is 150. What is the relationship between this angle and this angle? The line voltage is 30 degree plus the phase voltage. If you add 30 to this one, you'll get minus 90. If you add 30 to this one, you'll get 150. If you add 30 to the 0, you get 30. So this is the first thing. I know V line compared to V phase, it's gonna have plus 30 degree phase. This is what we call phase. And this is the line. So the line to line, we call it V line. The neutral to the point, cross the phase, we call it phase voltage. Now, what is the relationship between the magnitude 415 and the 240? If you divide 415 by 240, you're gonna find it is square root of 3, exactly. So it is square root of 3. So if I don't have the line voltages and I have the phase voltage for Y connection, take the magnitude multiplied by square root of 3, take the angle, add 30 degree. Okay, take the angle and add 30 degrees. So this is the relationship between line voltage and phase voltage for Y connection. Is this okay a little bit? Yes.
Sir, can you explain the division part again?
Okay. If you take the line voltage, the magnitude 415, and you take the phase voltage 240, the ratio between them, if you divide them, you're gonna find it is exactly square root of 3. So it means V line divided by V phase, the magnitudes only, will give you square root of 3. From here, V line equals square root of 3 times V phase. I'm talking about the magnitude, not the angle. Now the angle, clearly you add 30 to get the line. Now I'm gonna give you a couple of examples on this, okay? We have Y connection source. The voltage is 80 angle 20, let's say. The voltage here, this is A, B, C. The voltage here is going to be 80. If it's a positive sequence, so it's minus 100. 20 minus 120. Then this is 80, 140. Someone says, okay, find the phase voltages. That means the phase voltages VAN between this point and this point, VBN, and VCN. This is Y connection, by the way. What is VAN between this point and this point?
#80 angle 20.
80 angle 20, yes. Then between B and C, it's this source. So 80
Angle
minus 100. Then 80, 140. Now, if someone says find the line voltages, you're gonna say, okay, those are between lines. So line A to line B, line B to line C, and line C to A. Okay. So how do we do it? We say V line equals square root of 3 times V phase and angle 30. So I take the first one, 80 multiplied by square root of 3. How much is that? 80 times square root of 3. I got an answer 138.5. Okay. So it means, oops, 138.5, right? This is what I got. So 138.5, 138.5. This is how we find the line voltage. It's this minus that. You can do 80 angle minus 100 minus 80 angle 20. You're gonna get this number. Now for the angle, we're gonna add 30. So this will be 50. When I add 30 here, this will be minus 70. When I add 30 here, it's gonna be 170. This is how you find the line voltages for the connection Y. Is this okay? VAB, basically, another way to do it is just VA minus VB. So you take VA minus VB, you're gonna get this answer. A quick way, you just take the magnitude, you multiply it by square root of 3, and the angle, you're gonna add 30 degree to it. So you take 80 times square root of 3 and add 30 degree to this angle. This is for the Y connection. Are we okay here?
Yes, sir.
Okay, now there is another thing for Y connection, which is the current. Now, there is a phase current and line current as well. So I'm gonna erase this. This is the Y connection again. The three sources. There is a current coming from the source and current going to the load. Current coming from the source, going to the load. Coming from the source, going to the load. The current going through the source, we call it I phase. The current in the line, we call it I line. Now, what is the relationship between the phase current and the line current here? The current going here and the current going here. Are they equal or not? They're the same because the current going here is going to go here. So I line equals to I phase. This is for Y connection. Now we get to the rule at the end. V line equal to square root of 3 V phase and angle plus 30. You're going to add 30 degree to the phase. I line equals to I phase. This is for Y connection. This is V phase. Between here and here is V line. They're not the same. This voltage, the V line, is not the same as this one. You can see that clearly. V line is bigger than the V phase. You see between these 2 points. While when it comes to the current, I line here in the line, I phase is going here. And you can see the I phase equals to I line because what comes here goes through the line. The line voltages VAB, VBC, VCA. The phase voltages VA, VB, VC, and sometimes they put N, just to show it's between A and N. If they don't write N, it means it's N. N is like the ground in neutral, so CN. VAB is VA minus VB, or another way, it's square root of 3 times VA, and you add 30 degrees. While the line current and the phase current are equal, so I don't have to explain this. Is this okay for the Y connection? So this is the Y connection. Now we're going to do delta connection, the other one. We said delta connection when you have sources. This is going to go to the lines, to the load. It's going to go to the load. Delta connection, we connect it this way. We take this point, we connect it here. This point, we connect it here. And this point is going to be connected to this. Positive, negative, positive, negative. Polarity, it's still AC, but we put the polarity. So this is called delta because I actually can draw it in like delta. This is A. This is B. This is C. This end here, say A prime, B prime, and this is C prime. So I take A, source, C source, B source. So this is A prime, B prime, C C prime. So look at the connection from A prime to B. So from A prime to B. This is this point, B. From B prime to C. From B prime to C. This is this point. It's going to be to C. So this is this point. Like this. Then from C prime to A. So from C prime to A goes like this. And this goes like this. Plus minus, plus minus, plus minus. This is exactly like that connection. It's the same thing, but we draw it in a different way. We draw it in this way, so it looks like delta. This is why we call it delta. Does this make sense? Why you see right now the two drawings are the same? Yes, no. Yes, no.
Yes.
Okay. So now we want to take delta and see what is the relationship between voltages and currents. Line voltage, phase voltage, line current, phase current for delta. So what I'm gonna do, I'm gonna just put delta here. So this is the connection delta, the way it looks as delta. So this is A. Say B and C. The order is not. So this is now the voltage between this point and this point is called phase voltage. Like here, it's across the source. The voltage between this point and this point is called the line voltage. What is the relationship between them? This voltage and this voltage. Are they the same or not? Look at this point. Is it the same as this point? Look at this point. Is it the same as this point or not? If they're the same points, then the phase voltage equals to the line voltage here. You think they're the same or not? Any answers? This point is basically, yeah, this point is actually connected to this connected to this. So what is across the voltage here is basically the line voltage. So here V line equals to V phase. But if we look at the current, it's not going to be the same. The current going here, I phase, inside the phase, is not equal to the I line. So there's phase current going here. It's phase current going here inside the phase. And there's three line currents. This is line current and this is line current. Here the line current does not equal to the phase current. And if we do values, we plug a number here and a number here and a number here. Number here and number here, and we try to find that one. Here at this point, this is leaving, this is coming, this is leaving. If we plug values, let's say this current is 5 angle 0. This one here is the C one, the C line, right? So this is 5 plus 120, let's say. IL is leaving the point, this knot. And what else is leaving? Sorry, plus 5, 120 is leaving. This is leaving. Equal to 5 angle 0. So from here, IL will equal to 5 angle 0 minus 5 angle 120. If you do the calculation, you're gonna find the angle is minus 30. And if you're gonna find the magnitude is a square root of 3 of 5. What does that mean? I line equals square root of 3. Oops. Square root of 3 if I phase, and you're gonna subtract 30 degree. You can try it with different numbers, but at the end, this is what we have. Okay, this is what we have. The summary of this. For Y connection, I line equals to I phase. And this is clear. The current here equals to the current here. I phase equals I line. The same. Now for delta connection, V line equals V phase now. And this is clear because this is between cross the phase, it's called V phase. And between the lines, it's called V line. And we can see they're the same. What is cross the phase and what is between the lines is the same. Now, the other value, if the current is equal, the voltage is not going to be the same here. Voltage line will be square root of 3 V phase. Here, I line will be square root of 3 I phase. So this is basically the relationships and the connections that we want to talk about. And I think it's very clear that in the Y connection, I phase equals to I line. And it's clear that the line voltage is not equal to the phase voltage. Same here, the current here is not going to be the same as the current here because there is an intersection. And when the phase value and the line value are not the same, the line is bigger by square root of 3. Okay, can I clear this and go to the lecture? I don't have a lot of time, but I'm gonna actually just go through it very quick. So this is where I stopped last time. These are the two connections for the sources, okay? Then we take the phase values cross the phase and the line values cross the line, okay? Line current, line voltage, phase current, phase voltage, phase current, line current, phase voltage, line voltage, just where they are. Then these are the values, the relationship in Y connection. Line current equals phase current, while the line voltage is square root of 3 of the phase voltage. Then those are examples. Then when we do delta, that's how we connect delta. In delta, line voltage, phase voltages are equal. Line current is square root of 3 of the phase current. And this is an example here on this. So we can go over this on your own. We're gonna go over them quick next class, just to see those ones. This is good thing to review here. The concept of the phase, where is it? D line, what is it for currents and voltages, and Y connection and delta connection? Any questions? You need to take the attendance. Okay, Abdullah Khalid.
Yes, sir.
Muhammad Mohsen. Hassan Abu Hassan. Rand.
Sir Hassan, I'm here.
Okay, thank you. Rand. Yazan. Sarah. Abdullah. Abdullah Ali. Maryam Ahmed.
Here, Mister.
Okay, thank you. Abdullah Ahmed. Ahmed Al-Tayyib. Asma.
Yes.
Yusuf.
Sir, can you repeat the name because it was not clear?
Muhammad Yusuf.
Yes, it is me.
Thank you. Leen. Fahad. Amal.
Yes.
Abdullah Hassan. Hazim. Samar.
Yes, sir.
Thank you. Ziyad. Awatif.
Yes, sir.
Thank you. Isam. Thank you. Manal.
Yes, sir.
Thank you. Hamad.
Yes, sir. Yes, sir. I'm here.
Asia. Sharif. Ahmed Taha. Okay. So people who are not here, Muhammad Mohsen, Rand, Yazan, Abdullah Ali, Abdullah Ahmed, Ahmed Al-Tayyib, Fahad, Hazim, Ziyad, and Sharif. Okay, thank you guys. I'll see you inshallah tomorrow.